Hi guys, it's lesson 2.7, dilating lines. All right, we're going to get right to it. So the first thing I want to do is just practice graphing a line and make sure that we remember this from Algebra 1. So some basics, the equation of a line. This is one of the few things I feel like everybody always remembers. Y equals mx plus b, where m represents the slope. And we talked about the slope a little bit in our last lesson. And then b represents the y-intercept. And so slope, hopefully you recall, since we did talk about it in the last lesson, rise over run. Now I tend to write it as change in y over change in x, but there's a lot of ways that you can think of it. So when it's in mx plus b form, we want to start by plotting that y-intercept first. So when we say 2, we really mean the point 0, 2. So we'd start up here at positive 2. And then you're counting out your slope from here. So if a slope is negative, it should be slanting down to the right. Now, when we say negative 1/3, we can go down 1 and right 3, or we can go up 1 and then left 3. Either way, I'll get it done. So if we go down 1 and then right 3, that works. Or we could go up 1 and left 3. Either way, you should produce that same slant where it's down to the right as you look at it from left to right here. Right? So just doing some quick practice. There we go. All right. So the same thing for the second one. If it's not already in mx plus b form, you need to get it into y equals mx plus b form. So subtract the 2x on over. I would suggest squeeze it in front of the constant. So it reads as negative 2x and then plus 12. And then divide everything by the negative 3. That's important. Otherwise, it's going to throw your answer off here. So negative over negative, we can change that to a positive 2/3 x and then minus 4. So again, y-intercept first, come down to negative 4. So negative 1, 2, 3, 4. So we're starting on the y-axis always, and then counting out our slope. So a slope of 2/3 means we're going up 2, and then we are going right 3. So up 1, 2, over 1, 2, 3, and you can repeat that. Or just like last time, we could say, let's go down 2 and left 3. So down 2, left 3. Either way, it should work. Now, if you have a graphing calculator, you could absolutely use your graphing calculator to assist you with those graphs, but you would still need to make sure that you could get it appropriately into y equals mx plus b form first. If for any reason you're not remembering this, make sure to ask for some help because it is pretty much expected that that quick review should cover your bases there. Otherwise, down at the bottom, dilating a line. So the whole point is there's an infinite number of points on the line. If we can dilate just 2 of them, that gives us enough to move the entire line accordingly. So when it says find the equation for the dilation of the line y equals 1/2 x plus 4 through the point 4, 3 by a scale factor of 2. All right, there's a bunch of stuff. Start here. We want to sketch these or draw these. All right, so we've got y equals 1/2 x plus 4. We're going to start up at 1, 2, 3, 4, and then count out our slope of 1/2. So up 1, right 2, up 1, right 2, or down 1 and left 2. So get at least a fair number of points on there so that your line is pretty accurate and it doesn't kind of meander off to no man's land. Then we have the point 4, 3. So right 1, 2, 3, 4, up 1, 2, 3. That is our center of dilation. You can label it O, you can label it C, whatever you like, all right? Just make sure you understand what's going on. So since the scale factor here is 2, we are going to want to use what we did in the lesson yesterday, or in lesson 2.6, to be able to dilate a couple points from this center of dilation right here. What I would specifically do is use the easy points. So I would use the ones directly vertical or directly horizontal from it. And since we need to move 2 points, those would be the 2 I would pick. Right? Since we have a scale factor of 2, let's come on in here, give ourselves the line to extend out from. So I'm going to extend out vertically, extend out horizontally. Now, to be honest with you, I could skip drawing those lines in, and you could still get away with this, but I want you to see how it connects to what we did in the last lesson. So right here, if I count out from O to, I'll call this point A, right? So I'm going to say from O to A, I'm just counting up 1, 2, 3. And then it would technically be, right 0, but don't overthink it. All right. So I'm going to repeat that. So repeat this. So I'm just going to go up 1, 2, 3 again. And that's where A prime moves to. Mm-hmm. And now I can call my other point, point B, just to make it easy to talk about. And that is the one directly to the left of point O. So that means the distance from O to B is over 1, 2, 3, 4, 5, 6. So I'm going left 6. And now, same thing. Let's repeat that. So I'm going to go left 1, 2, 3, 4, 5, 6 again. And I only do that once because I just want the distance to double. So if the distance was 3, it's now 6. This one, the distance was 6, it's now 12. So that's how the dilation has a scale factor of 2 there. All right, and then go ahead and connect from A to B. Now keep in mind, it's not just a segment, it's a line. So you're going to not just connect, but you're going to extend beyond it. So A prime, B prime is just how I happen to have labeled mine. But what we should be looking at now is a line that is twice the distance away from point O as it was before. So what that means is each individual point is now double the distance from point O that it was on the first line. When it says find the equation, all right, well, to find the equation, I need 2 things. I need the y-intercept, and I need the slope. So let's use the graph. The y-intercept, count it out. We got 1, 2, 3, 4, 5, 6, 7. So that's my b value. And the slope, I can go from any 2 points I know. So I'm going to use the 2 that I have here. To go from b prime to a prime, I'm going up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the slope up 6, right 12. That will simplify down to 1/2. That is my m value. So now when I write it in terms of y equals mx plus b, I can just fill in. I have y equals 1/2 x and then plus 7. That is my answer there. All right. Let's try another one and see how it goes. So on to the next page here. It's saying you've got line L mapped onto line M by a dilation centered at -4, -1. So let's plot that. -4, -1. All right, I'm going to call that O. That's going to be my center of dilation there with a scale factor of 4. All right, the equation of line L is 3y equals x, or excuse me, plus x equals -3. All right, so line L is 3y, geez, I keep saying that wrong, plus x equals -3. All right, let's rearrange. So to get y alone, move the x to the other side. So we're going to subtract it over. I'm going to put it in front of that -3 and then divide everything by 3. So I'm going to get -1/3 because there's a little 1 in front of that, x, and then -1. All right, so that's the equation of line L. Let's go ahead and get that drawn on the graph. So the y-intercept at -1, slope is down 1, right 1, 2, 3. Or I could go up 1, left 1, 2, 3. And I could keep repeating that. All right. Make sure you are using your straight edge for this. There's no reason for things not to be nice and neat. Also, you will confuse yourself because the line will eventually start going through the wrong points if you don't use a straight edge. So let's see. Line L is mapped onto line M, but they're trying to tell us, figure out what line M is. So it's just a different way of saying find the equation of the line that once you do a dilation centered at point O with a scale factor of 4. Okay. All we need to do is we need to move 2 points. So we're going to dilate 2 points, right, on the line. That's it. If we can do 2, that'll do it. I would always say pick either the ones that are directly vertical or horizontal from it, or if you don't have those points, then the ones that are pretty close by. We do actually have one that's directly horizontal from point O, so that would be this point. So I'm going to pick that guy. And then I have the ones that are pretty close by, so maybe I'll pick like this guy right here. All right, and so just so that I can talk about them, I'll call those A and B. All right, so right here, I can say it's the slope from O to A, or I can even just say it's the distance from O to A, because since it's horizontal, I can just simply count it. So if I go over 1, 2, 3, 4, that little distance is 4. Now to do a scale factor of 4, I got to repeat that 3 more times. So if I went over 4, I'm going to go over 4 again. So 1, 2, 3, 4. I would have to go over 4 again. 1, 2, 3, 4. So now I've tripled the distance. And I'd have to go over 4 again. 1, 2, and I fall the tiniest bit off the graph. Now, if I'm not too far off, I can probably still get away with it. So we'll see. All right. If you fall way far off the graph, no, pick a different point and start over. Okay. So I'm gonna go with what I've got here. So now the distance from O to, if I call this guy way out here, A prime, is now 4 times this. So it should be 16. So if I actually count, here's 4, 8, 12, 16. Okay. The ones that are closer by is going to make this a little easier. So if I now use the slope from O to B, that's a nice easy one. It's going to go up 1, right 1. And now because this one's at a slant, I'm going to draw my line in just to kind of keep me honest with this. Right? Because I know that that point is going to extend out from there. Right? So right now, to go from O to B, I go up 1, right 1. So that's my slope, is to go up 1, right 1. Or I can write it like this. I need to repeat that 3 more times. So if I go up 1, right 1, it moves to here. Up 1, right 1, moves to here. Up 1, right 1. There we go. Right? So I don't repeat it 4 times. I only repeat it 3 because the first one is already kind of my distance of a scale factor of 1. And then scale factor 2, scale factor 3, scale factor 4. So that's going to move the point that I called B to B prime right here. All right? And so if I can now connect my little A prime to my B prime, let's see if this looks okay here. I end up with that. So now I would need to be able to create the equation because this is what we said is line M now. So for line M, I need the slope. I need the y-intercept. Well, nicely enough, point B is the y-intercept. So that's the point 1, 2, 3, 0, 3. Right? And then if I need the slope, this could be a touch trickier, but we can try it. From here, we're going to come down 1, 2, 3, 4. So -4, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, if we simplify that, that comes down to be -1/3. So when we go to write the equation of line M, it should be y equals -1/3 x, and then there's our y-intercept of +3. Whew, that's a lot of work right there. But there should already start to be a couple things that you're recognizing. If we look back at the one before, we started with the line 1/2 x plus 4. Our answer was the line 1/2 x plus 7. Here, once we rearranged it, we started with the line -1/3 x minus 1, and we finished with the line -1/3 x plus 3. So what we should be seeing here are some similarities. The fact that we have the same slope is actually pretty important. Not only does it kind of make our work a little bit easier to check, but those same slopes, you might also notice that if they have the same slope, that those lines are then parallel to each other. All right, we're going to save number 3 to recap in class. So if you think that you might need some help with that, make sure that you log into class tomorrow so that you can see it. All right, let's move on to the next page here. So it's saying we've got line L mapped onto line M by a dilation centered at 4, 1 with a scale factor of 1/2. All right. So 4, 1, 1, 2, 3, 4, 1. So there's my center of dilation. All right. Scale factor 1/2 means that instead of doubling out the distance, we're going to be cutting it literally in half. So let's take line L that's being given. It's x plus 4y equals 8. Let's rearrange. So we can subtract the x over, divide everything by 4, which makes it negative 1/4 x, and then plus 2. All right, get that guy on your graph. So y-intercept at 2, counting out a slope of down 1, to the right, 1, 2, 3, 4. Down 1, to the right, 1, 2, 3, 4. All right. So here is our line L. All right. What you might have already started to notice is that line L goes directly through the center of dilation. So if I ask you to dilate the points, can we do it? Technically, yeah, we can. All right. So just as an example, if I took like this point right here, the y-intercept, which is I know is on the line, I'm going to call that A. And if I said, I want that to move so that it is, half the distance away from O that it is right now, well, I'd have to look at the slope. So to go from O to A, I go up 1 and left 4. If I did half of that, I'd go up a half and left 2. So A would slide in closer to O and it'd be at A prime. But no matter what point I move on the line, whether I move A or maybe I come down here and call this B, it's still going to slide and land on the line itself. So the answer I end up with is the points will technically have moved, but it'll still create the exact same line already. So when it says determine and state the equation for line M is the same as line L. It would be y equals negative 1/4 x plus 2. So if the center of dilation is on the line, then the image will be equivalent to the pre-image. It stays the same. We got a couple cool last cases to look at, and that is dilating by a negative scale factor, and then also some that are done out for you and kind of working from there. So at the bottom, get your compass and your straight edge back. All right, it says dilate a line segment AB by a scale factor of negative 2. All right, it's not that it folds into itself, but the negative changes the direction. All right, so when you have a negative scale factor, it changes the direction. So instead of going away from point P, you're going to go through point P to the opposite side. All right. So what it means is the image will be on the opposite side of the center of dilation. And I'm hoping that where I'm writing the notes will not fall too much into the way of our actual diagram here. So what that means, instead of going from P and extending past A, I want you to go from A and extend your line past point P. And then do the same thing from B. Line it up and extend the line past point P. So now what we are going to do here is you're going to take your compass. Let's start with P to A first. And you're going to open it that little distance. And then I want you to swing the compass around so that it's on point P and you swipe a little spot equidistant to the other side of point P. That would be a scale factor of negative 1. So I move the same distance away, but to the opposite side. So if I want a scale factor of negative 2, plot your pointer right here, or put your pointer there, and go 1 further. So that down here is where A prime would land. So if this is my little distance x, coming this way would be a little negative x, and here would be another negative x. So here's where you get the idea of like the negative 2x from, all right? And now do the same thing with P to B. Open, so adjust your compass, so that it matches that distance, and then swing it around to the other side of point P. Mark that distance, and then do it one more time because I want to go 2 times that length in the opposite direction. So that's going to give me point B prime over here. So keep in mind this little length here is now doubled and on the opposite side of point P. Okay? So now we can just take our pen or pencil and connect the dots so that here's A prime to B prime. So it's dilated to be twice the length, but in the opposite direction. We have one last type of question to look at. Let's move on to that last page here. It says, find the center of dilation of the scale factor. All right. Well, regardless of what we've seen, if we're looking for the center of dilation, that means that if you connect the dots between any point and its image, and then I repeat it for all the points on there, they should all intersect at the center of dilation. So let me show you what I mean. Take a straight edge. Take your pen or pencil, and I'm going to use mine in red just so you can see it. I'm going to line up P and P prime and draw a line through. And I want you to repeat that process. Draw Q to Q prime. And then I want you to connect the dots for R and R prime. That's R right there. And what you should see is that all 3 of them intersect up here. And now I think my first line might be a touch off, so I think my point maybe should be right here, all right? But to find the center of dilation, you just have to connect through the dots, connect through the dots, connect through the dots, all right? So if you connect P and P prime, Q and Q prime, and then R and R prime, the lines should all intersect at the center of dilation. And then as for what is the scale factor? Well, the scale factor, you can look at the actual lengths here. Okay? So if I look at the length from P prime to Q prime and compare it to the length of P to Q, so that length, and I picked that one specifically because I can count it. It's 1, 2, 3 versus PQ is just 1. That's my scale factor right here. All right. So if we do one more here, I'm going to slide up a touch. If I connect from C to C prime, and then from B to B prime, so try to be as accurate as you can. And then A to A prime would actually give me that exact same line right there. Where they're crossing is right here. This looks like the point 1, -1. So my center of dilation should be 1, -1. And then as for my scale factor, you can always use the image divided by the pre-image. So find 2 lengths that are easy to use here. I would suggest the horizontal ones. So if I use A prime, C prime, and then A over C, or excuse me, AC, that would be the easiest ones here, all right? And so A prime, C prime is actually this little guy, 1, 2, 3. A to C is the larger segment, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And so my scale factor, that would reduce nicely down to 1/3. All right, we'll save number 8 for a little recap in class. Don't forget to go answer, don't forget to go answer the post video question, and thanks for watching, guys.